Okay, so what we're going to try and do here is we're going to try and figure out which of these four solutions right now has the strongest acid in it. We're going to label that 1 and then so on and so forth. So I love how in all these they had different colors just to confuse you. But I wrote a basic, or I grabbed one of the basic water or acid dissociation equations. So we know that anytime we throw an acid into water, it's going to break apart into H3O plus and A minus. The more H3O pluses and A minuses that are in the water, the stronger the acid is. So what we're looking for in all four of these is we want to see which ones have the most H3O and A minuses and the least amount of HAs. The waters are just in there for cover. So we can actually just count them if we wanted to and see what our numbers are like. So if I look in this first container right here, I see only one HA, and then I see 1, 2, 3, 4 A minuses, and then I see 1, 2, 3, 4 of the HAs. So if I were looking at this, I would have one of the HAs. Actually, I probably want to do that in permanent. We have one of the HAs, and then I have 4 of the H plus and 4 of the A minus. So that's a pretty strong acid here. Let's look at the second one here. Now, this is the exact opposite here. We have 1, 2, 3, 4 of the HAs, right? And if we take a look at the A minuses, we have 2 here, and then we have 1, 2 here. So we have 2 H pluses, and we have 2 A minuses. So if we were comparing these two to each other, we know for certain that this guy right here is a stronger acid than this guy is. But let's take a look at the rest of them and see what they look like. So let's look at the third one. Third one, we count 1, 2, 3, 4, 5, 6 of the HAs. That is so many HAs. We see 1 A minus and we see 1 H plus. So we have 1 H plus and 1 A minus. This is a very weak acid because the majority of them stay as HA. And then finally, let's look at this guy. And this guy just said, you know what, let's 100% break apart because I don't see even one of the HAs in here. And then when I take a look at my H pluses or H3O pluses, I have 1, 2, 3, 4, 5 here. So I have 5 H pluses. And I could count them if I wanted to here, but I'm going to use the marker 1, 2, 3, 4, 5 of the A minuses. We could probably assume, because it's a 1-to-1 ratio, that this is the case. So of all these, which is the strongest acid? Well, it has to be this bottom one, right? So this is going to be number 1 because all of the HA dissociated. Then this one right here, we already compared. This one here is going to be the weakest, right? Because almost all of it stays. So that's going to be number 4. And then between these two, we said that this one right here, it breaks apart to 4 and 4, and this breaks apart into 2 and 2. So this is going to be my second best, and this is going to be my third best. It seems weird to do this, but College Board loves giving you problems where you have to count things out and see what they are. And if you're able to wade through the fact that what I gave you here is an example, and this is, by the way, they don't even give you this. I pulled this in here just so you could have a visual of this. Our different colors, it works out okay. Hopefully this has been helpful.